Today we will understand identity a square minus b square is a plus b, a minus b. So how you will remember that if there is a square, you leave the square and write a minus b and a plus b. Let's see how we got to this. Now this cannot be solved further, so we will open up these brackets and solve. So let's open up the brackets. This is a plus b, a minus b. So a into a is a square, b into a is ba, and there is a plus sign. A into b, that is minus ab, and b into b is b square, and there is a minus sign. So let's understand once again. A into a square, a into b, ab, and b into a, ba, and b into b, b square. So what we have done, we have multiplied a and we have multiplied b with also a in this case, and then we have multiplied ab and then we have multiplied b. So after this multiplication we have got this. Now commutative law says ab and ba is same, so we can write a square plus ab. BA is equal to AB, so I am writing for BA AB minus AB minus B square. Now plus AB minus AB is 0. We have done, when we have done addition of algebraic expressions, we open up a bracket, we write the algebraic factor outside, and let me copy this minus B square. So AB coefficient is 1, I copy the coefficient 1. For this AB, coefficient is minus 1. So 1 minus 1 is 0. 0 multiplied with any number or product is 0. So if you multiply anything with 0, you get a 0. So this term goes away. So I get a square minus b square. So this is the way how you get this identity and how to remember this. If squares are there and a minus sign is there, you can write it as a plus b, a minus b. Let's take an example how to use this identity. So if they are saying find the product, find 6x minus 7, 6x plus 7 using identity. Now you can see this is similar to this. A 6x 6x plus minus and b is also there. So we can write it as 6x minus 7, 6x plus 7 is 6x whole square minus 7 whole square. So you must mention the identity whenever you are using it. So you can write this identity here that from a plus b, this is 6 plus x, a minus b, we have gone to this side. A is 6x and b is 7. So we have got a square minus b square. Let's find this. 6 6s are 36 and this is x square. 7 7s are 49. So using identity you can find the product. Instead of opening the bracket and solving it, you can simply use the identity and find the product. Let's take another example showing how the identity is used in factorization. So if they say factorize p to the power 4 81. Now you can see I want a square. So first let's take out the square. p square into 2 into 2 gives me 4. When we have done exponent laws, a to the power m and power is n outside the bracket, we multiply these powers. So 2 into 2 gives me 4, and for my identity I can see a square. Now 81 is square of 9, so I can write 9 square. Now you can see in this case p square is a, and what I have to write? A plus b, and this b is 9. So we can write p square plus 9 and p square minus 9. So when you are writing this right hand side, you can see a and b. You leave the squares and copy a and b in the bracket. First you add, then you subtract, keeping in mind that b has a minus sign before here. So in your answer also b will be written after this minus sign. Now we can not solve this further, but we can solve this further. So let's copy this as p square plus 9, and I have p square. 9 is square of 3, so I can write it as 3 square. Now you can see I leave these squares, and I write my answer as p minus 3 and p plus 3. So p square plus 9 is one factor. Another two factors are p minus 3 and p plus 3, and always mention the identity when you are using. You must, these first three identities, they are called your, we have done a plus b whole square is equal to a square plus b square plus 2ab. A square minus b square is a plus b, a minus b. And we have also done identity where this square is outside the bracket. All these three identities, you call them as standard identities.